So we want to graph this function here. And now it's an awkward function because it is a power 1 times a power 2/5. Okay, so we're going to first start with some zeros. So I'm going to start with some zeros of this function. And the zeros are easy because it is already factored. So we have zeros at x equals 0 and x equals -2. So I'm going to start making a table of values here. Okay, so I'm going to maybe sketch a table of values here. And at 0 and -2, so maybe -2, I'm going to spread these out because I don't know how many coordinates I'm going to need. I'm going to have 0 and 0, and I'm just going to draw that on my graph. So at -2, 0, and at 0, we have another 0. Okay, so that's where I'm starting at. I'm going to now find the derivative because I want to know what my slopes are going to look like. So f prime of x is equal to 1 times x plus 2 to the power 2/5 plus, using the chain rule, or sorry, the product rule, I get 2 over 5 x plus 2, and that becomes negative power 3 over 5. Okay, so we've kind of done this before in that to simplify this, I kind of want to get rid of that negative power in the numerator, and I want to put that in the denominator. I should also get rid of that divide by 5. So I'm going to do it like this. Okay, so I'm going to times the top by 5 and x plus 2 to the power 3 over 5. And then that needs to show up in the denominator to balance this off. So I'm going to get 5 x plus 2 to the power 3 over 5 positive. Okay, so when I do that, I'm going to end up multiplying 5 here. So I'm going to get 5 in the top. I get x plus 2 to the power 2 over 5 times 3 over 5. Well, that means that I'm going to get power 1. So I'm going to end up with an x plus 2 to the power 1 factor. That's very useful. Okay, so here the x plus 2 to the -3/5 and the positive 3/5 cancel out. The 5's cancel out. So I'm all left with just 2x. And then in the denominator, because I had to balance a fraction, I now have the x plus 2 to the 3 over 5 in the denominator. And it should end up there because notice that my original derivative in red is power -3/5, so that should end up in the denominator. Okay, so the green part is just multiplying by getting rid of some fraction parts there. So there's my derivative, f prime of x. Okay, I'm going to simplify this expression because I want to solve for some zeros here. So I get 5x plus 2x. That's 7x plus 10. I can find zeros from that. I also have a restriction at -2 because I can't have my denominator equal to -2. And then I can start doing my slope chart here. So I have a zero, the derivative is equal to 0 at -10 over 7. So I'm going to have -10 over 7 right about maybe here, -10 over 7. And then at -2, I have an undefined slope. Okay. And it looks like I don't have any other changes in slope here. So I'm going to then do a test. I'm going to check my slope at -3. So plugging -3 into this expression, I'm going to end up with, I'm going to do this with signs, so negative in the numerator, and then in the brackets, I'm going to end up with negative to the odd power, so that should be negative. So I'm going to have positive slope in here. So that's going to be positive slope. It's going to be going up to an undefined slope point. So it's probably some kind of kink in the graph. Okay, so between -10 over 7 and -2, so that's maybe going to be, I'm going to try 1.5 because that's going to be in between there. When I plug -1.5 in, I'm going to end up with negative on top, okay, and then 1.5, I'm going to end up with positive on bottom. So that's going to give me negative slope through this region here. So I know I'm going down. So it's probably a kink. So it's probably going to go up like that to the 0 and kink down. Okay, that's what I'm anticipating based on what I'm seeing there. Testing my slope at x equals 0, f prime at 0. I'm going to end up with positive on top. I'm going to end up with positive on bottom. That's a positive slope. So it looks like it's going to be a minimum point here and then sloping up like that. Okay, so I probably should find the x coordinate of my minimum point, which is going to be at negative 10 divided by 7. Okay, so plugging that into my equation, I'm going to end up with, I'm going to have to do it over here. So f of negative 10 over 7, that becomes negative 10 over 7. And that's going to be positive 14 over 7 plus negative 10 over 7. That's going to be positive 4 over 7, but that's going to be to the 2/5. So I need to plug that into a calculator, I think. And so plugging that into my calculator, I'm going to get that minimum point is going to be at negative 10 over 7 and negative 1.14. I'm going to round that to negative 1.14. So I can draw that coordinate in. So that's going to be right about negative 1.14, maybe right about here. Okay, so there's my minimum point. Okay, so I can then pretty much do the graph at this point. Okay, I should maybe do endpoint analysis, but I know that the limit, I'm going to do that over here, the limit as x approaches infinity of f of x is just going to be positive infinity. The limit as x approaches negative infinity of f of x is going to get me to negative infinity. So then sketching in the graph, it should give me a positive slope to here. Yeah, I don't know the concavity, but it's going to be concave up because that's a minimum point. It's going to go through the 0, and it's just going to keep on going up. And I don't know if there's a change in concavity here or not, okay, but we're not being asked to find that.